Please have your pen and copy with you. So, good morning, everyone. In this session, we'll discuss about the question and answer from the data analytics. So, first topic we'll cover is the regression modeling. So, I will suggest you that all of you have a pen copy so that we can, if you have any query, we can share that queries in on. And we'll use the a Google Drive to share any queries, and as well as we can also use the WhatsApp so that we can get a response from one of each others. Okay, as the medium possible. Okay, so what is actually a regression model? We have discussed. So from a question point of view, if you want to plot n pairs of data, and data is representing as x and y, there are two dimensions in data. So here x is representing your predictor variable and y is representing your predicted variable, as we have discussed in a unit 2. So whatever the value of x, the value of y will be depend on that. So there should be a relationship between the y and x. So if we'll plot n pairs of data x and y, so what happened? We will get a multiple point, and each point will be represented by x and y. So if you draw this plot in XY axis, you can find out that for every value of x, there will be a value of y. For example, if you can find out the uh, real estate price with respect to the distance from airport. So as this distance from the airport will be increased, the real estate price will be decreases, because everyone wants to stay near the airport. So basically in this session, we'll discuss about the linear relationship. So what is a linear relationship? It will basically represented by the relationship between the y and x in a linear function. There are non-linear relationship between the variables. So we will discuss those things in a later session. In today's session, we will only discuss about the linear relationship between the y and x. So method, we can use the least square method to solve, write the linear relationship between the x and y. So what is a least square regression line? That is an example of regression modeling. So basically, if we talk about the regression, least square regression line, so it's look like this. One, let me minimize it. Okay. So you can see there are 4 data points, D1, D2, D3, and D4. Now, we have a x and y axis. So every data point is represented in the form of x, comma, y. Now, what happened? If you'll draw an equation, if you're trying to find out a relation, so this line can be represented by y equal to ax plus b. This is a simple linear line. So you can represent this line as a y equal to ax plus b. Now, when you draw this line, you can find out that there is a difference between the observed value. So this is observed value and this is a predicted value. So predicted value falls on the line, and observed value is the actual value which is you have got from some experiment or some from data set and so on. So you can find out there is a difference between D1 and the this predicted value and the observed value. Again, you have again difference between observed value and predicted value. So there are D1, D2, D3, and D4. There are 4 points, and all of them has some differences between the observed value and predicted value. We call this thing as an error, because that is error, because if you're trying to draw a line, line should be fall like this, going from D4 to D3, then D2, then D1. Then it will satisfy all the point. But initially we have taken a linear line. So what happened? There is a difference between the observed and predicted value. Now our task is to minimize this error. So if we trying to minimize this error, then we'll get a line which will have a minimum distance from these observed points. So maybe your line can be starting from this one, go to D2 and D3 and so on. So, so when we use the least square regression line for set of n data point, then equation can be given by using the y equal to ax plus b. So there are two coefficient here. One is a, one is v. X is the predictor variable which is available to you. You have to predict the y. So if you have x and y data points, so based on those data points, you have to find the y equal to ax plus b. So now we have to find these relationships. So actually, what we are trying to find, we are trying to find a and b. If we are aware about the a and b, we can put those value and we'll find this equation y equal to ax plus b. So how can we find the A and B? So in a linear regression, you can find the A coefficient A by this formula. So you can see that X and Y. So X is the data point. So if we represent the X data point, so you can find here that if it is x1 point, so it will be represented by two values x1 and y1. Again, this is a data point d2, so it will be represented by x2 and y2. Again, d3, it will be represented by x3 and x3 and y3 and so on. So there are four data points, so that all be represented by x1, x2, x3, y1, y2, y3 and y4. So each data point has a pair of xy. So to find out the coefficient of A, we have to take n. N is a number of data point, because here it says n data point. So n is a number of data point, and x1 and y1 is any given data point. So you can find out that I equal to 1 to n. So we have to calculate uh, the summation of x1 and y1. So we have to multiply each and xy variable and take a sum of those variable, and again multiply it by the n. I will then will subscribe the x1, will take a sum of only x values up to the n, then we'll multiply those value to the y value, and we'll take sum of y value up to the n. We multiply both variable, then we'll subscribe to the this section. Again, in a denominator, we have took the x square. We are taking a value of x. We will take a square of those values, then take a sum of it, multiply to n. Again, we'll take a x value. We'll take the sum of that, and the whole sum will be squaring. So by putting the values in this formula, we'll get the A. And again, for the B, we have this formula, which will be represented by 1 by n. So here, n is the total number of data point. Y is the values of y for a given data point, and x is a value of x for a given data point. We have already calculated the A, so when we put the A here, we'll get a B value of B. Okay, so now, you can write this formula, but we'll come back to it. Let us go for one question. Then we'll come back to the formula and we'll calculate each and everything. Okay, so let us take a first example. Consider the following set of points. So here we have a three set of points. Will be represented by x1, y1, x2, y2, x3, and y3. So from this set of point, you can get a x1, x2, x3, y1, y2, y3. You will get y2 and y. Now we have to find the least square regression line for the given data point. So what is the meaning of that? We have to find this equation, y equal to ax plus b. And again, it says we have to, second question is, plot the given point and the regression line the same rectangular system of x. So that is a plotting. So it's a more of programming part. We have to basically find out the least square regression line. So for a given data point. So guys, you can see that we have the value of x and y. We have to find out the a and b. If we'll get the a and b from these equation, we'll get a equation of y equal to ax plus b. Now, so let us start the question. So we have this value -2, -1, 1132. Okay, so uh, let us organize the data. So we have a x is a minus 2, 1, 3, y is a minus 1, 1, 2. So we'll calculate some value. So we'll calculate xy will be this minus 2 minus 1 is equal to 2, 1, 1, 1 multiply 1 is a 1, 3 multiply 2 is equal to 6. And again, we'll take x square. So minus 2 square is a 4, 1 square is a 1, 3 square is a 9. Okay, here minus will be multiplied to the minus, it will again go to the plus. Then we'll take summation of each and every value. So minus 2 plus 1 plus 3 is equal to 2. Minus 1 plus 1 plus 2 is equal to 2. 2 plus 1 plus 6 is equal to 9. 4 plus 1 plus 9 is equal to 14. So we have x and y value. These value x values and y values are given. Based on that, we have calculated x square. Then we have calculated all these values. Okay, here it is a summation of x, summation of y, summation xy, and summation of x square. Now, we'll put these values in the formula from the given formula above. So, formula can be represented as, if you want to calculate the a, so n will be number of data points. So that is a 3. Xy, we have calculated summation of xy, that is a 9. Then we have calculated the summation of x. So you can see summation of x is equal to 2 and summation y is equal to 2. So we'll multiply 2 into 2. Then in a denominator, we have n equal to 3. And then we'll take summation of x square. So summation of x square is a 14. So we'll multiply with the 14. And then summation of x whole square. So summation of x is equal to 2. The whole square of 2 is equal to, no, one moment. I think there is a slightly mistake here. So if you'll calculate this value, I will get the 0.605 as a value of A. And again, I will put the value of A here, that is a 0.605. Then you will get a value of B, that will be 0.263. So I will, then we have a and B. Now we will calculate the equation of line. So this will be a graph representing by y equal to ax plus b. Okay. And your line will be y equal to 0.605 x plus 0.263. So that will be your line. Okay. So any doubt in this question? Anyone? It's a very simple question. You have a formula of A and B. You have to calculate A and B. Okay. One question from. Okay, I see, no doubt. So guys, now we'll go how to write this whole regression line modeling in the Python. So I have developed a one program in the Python. The complete code can be available here. So you can refer those code also. So to make this working model, we have to import NumPy library. Then we have to import the sklearn package. So we'll import the linear regression from the sklearn model. Now we have to define x and y. So we'll define x and y because when we are dealing with the linear regression model, it will take each and every value as an array. So we have to convert the value of the previous value as an array. So here we have taken a 5 values that is represented by the x, and here we're taking the 5 value, 6 value that is represented by the y, and we have put those value into x and y. Now we'll see that we have a array of x and y. So here x is your predictor variable and y is your predictor variable. Now we'll find out the relationship between the y and x. Now, so how to create a linear regression model in the Python? So just call of linear regression function, and the return will be stored in the variable model, and we calculate the optimal values of weight b1, b0, and b1. So just call the fit function from the model and pass the value of x and y. By passing this value, you are actually calculating the b0 and b1. So all the code is written inside the linear regression model available with the scikit-learn. Okay. Alternate code can be, if you don't want to write two line of code, you can write a one line of code. Here you can call the linear regression, and we call the fit function and pass the value of x and y. Now we have to calculate the coefficient, that was the a and b. So you can see here that we have to uh, uh, we have to calculate the coefficient of b. So we are representing a as a b0 and b as a b1. So calculate a, we have to call the function of model dot intercept underscore. This will represent the intercept of the particular model, and that will be the a. And we have to calculate, if you want to calculate the b, we have to call the model dot coefficient underscore, that will represent the slope. So what is actually intercept and slope? Let me go to the here. So here a will be this one, that is the intercept where it is crossing the y-axis, and the slope will be the actual value, which will be increased by the equation. Okay, let us come back the a and b. Okay, so now we have calculated the coefficient and intercept, so that will be called as the a and b. Now the value of b0 is like 5.63. So it will represent the model responses 5.63 when x is 0. So you can find out that as the x will be increases, your value of b0 will be increases. And as the value of b1, that is a 0.54, that the predicted response rise by 0.454 when x is increased by 1. So these are values which are constant, and it will be every y value with the increase of x will be increased response by the 0.54. Okay, so now uh, we'll predict the response. So you can take any value of x, and if you want to predict the response, you can write the model dot predict of x. When you are predict the value of x, it will provide you a value of y prediction. So what we are trying to do here, for any for given equation, we take any value of x and we can predict the value of y. So if I will run this code, then you find out that these are the predicted response compared to the x and y. Now, what will be the our equation? So we have already find the a and the b. Our equation will be y equal to a plus bx. So that is a 0.263 and so on, plus 0.605 into x, and your predicted response will be such that. Okay. In the last, we'll plot the whole equation. So to plot that, we have to call the matplot dot pyplot. So from that, we can call the plot function, which will take the x and y value, so will be represented for the circle symbol. And then we plot this model, we'll get the actual line and the data point. So this is our actual line, and these are the different data points that is reside along the line. Okay, so okay, so that was the our example of how to draw a regression model in Python. This was the actual example, that is a -213, and there are two second data point was a -112. So these are the x value, these are the y value. So if we'll go to the our example, let me go to our example -213. One moment here. So our given data point is a -2, -1, 1132. So we have put those data point in our program model, and then we're trying to find out the square regression line. That regression line must be satisfied these data. Okay, so we'll go back to the code. So as we pass the x and y value, and we'll call the regression model, you can find out that you will get your coefficient, and your equation will be y equal to 0.263 plus 0.605 into x. Okay, so if you'll go to the our answer, you can find out that the same answer will be calculated here. So your value will be same, that is calculated by the model. Okay. So let me go to the program and run the whole program for your uh, idea. One moment. Okay. Is Jupyter notebook is visible to everyone? Is Jupyter notebook is visible to everyone? Okay. Okay. Good. So now, so this is our program. So we have calling the linear regression. Let me uh, restart and clear the output. Then we'll get a better idea about it. Okay. So first we create import the package. So we are importing packages. Okay. So we have to import the NumPy array package. Then we'll import the linear regression model. And for plotting the diagram, we'll import the matplotlib.pyplot. We call this package as a PLT. So whenever we are representing the pyplot, we'll just write the PLT and we'll represent this package. Now we have taken an example. So let me clarify here. Our given data points are, so these are data point 5 comma 5. Then our next data point is 15 comma 20. Next data point is 35 comma 1 more, 35 comma 32. Next data point is 35 45 comma 22, and the next data point is 55 comma 38. Okay. Uh, so these are our given data point. Now, if I want to see how these data point look like, so let me split the cell here, and for a given data point, we just plot these point, and we'll see how this point will be look like. So one moment, let me import this package, otherwise this will throw an error. So package is being imported. X and Y is not defined. Okay, let me copy the data point here. So we have to copy the data points. Now we'll plot these data points. So you can see these are our given data point. So your X and Y is represented by these data points. Now we have to find out a linear equation that will satisfy all these data points. So actually our target is to find a line which will be represented by y equal to a plus b into x. So we have to find the a and we have to find the b, the interslope of this line. Okay. So now we'll proceed further and we'll convert all these data point into NumPy array. Okay. One moment. And we'll call the linear regression model. So when we'll call the linear regression model, you can find that it will return some values. So if we'll get these values, so it will represent something parameter that will be required in the regression model. If you do not want to call all these values, you can call the simple line of code. It will also return the model. What is the coefficient of determination? We'll discuss later. So right now we let me skip that. That is not required. we'll discuss what is a coefficient or determinism because that is a important part of regression model. Now we have the model. So you can see that we have the model. So if I will run the model, you will get a model that will have the linear equation that will be uh, trained on the x and y values. Now this linear equation will have some values a and b. So we'll call these values. So to call the b0, we'll call the intercept underscore, and to call the b1, we'll call the model dot coefficient underscore. These value will be calculated. So basically, this is a and this is your b. So you are having a y equal to a plus bx. So this is your a and this is your b. Okay. Now predict any response. So let me first copy the value of, let me copy the data point first so that it give me, oh, sorry, one moment. Okay. So these were our given data point. So guys, if you want to predict any value of x, so you can take any value of x from here to check that your model is okay or not, or you can take any value of anything that will be out of this data point, and that will be represented by the y predict. So when I will call the model dot predict, I'm passing all the values of x. So you are passing the 5, 15, 35, 45, and 55. Now whatever the values that will be close to the this one. So for the 5, you are getting these responses, that is 8, 13, 19, 24, 29, 35. So you can find out that for the given data point value of y, you are getting a value of uh, observed. These are the observed values. These are the predicted values. So there are slightly difference between these values, but they are closer to those values. Now we'll find out the equation. So this will be equation y equal to a plus bx, or you can represent at y equal to ax plus b, whatever way you want to represent it. But that is a slope and that is your intercept. So you will get the values. Now to find out any values, you can just put down this value of x, and you will get a corresponding predicted value of y. Now I will plot these values. So first, what I will do, I will plot the data points as we have already done, and then we'll plot the line. So you can find out that this is the line and these are the different data points. So there are differences between the observed value and the predicted value. So we can apply the least square equation to minimize this one. But that is the best fit model using the linear regression model. Okay. Now, now come back to our program. One more. Okay, so yeah, this was our example that we have discussed. So for this given example, we have values -2, -1. Then we have value 1, 1. Then we have value 3, comma 2. So there are three data points. Now we'll find out the least square regression line. You can solve the numerical problem using this table and this for A and formula for calculating A and B, or you can just go to the program and run the whole one. So our data points are, one moment, let me, so our example is this. Consider the following set of points. So these are the set of points we have to find out the regression line. So we'll pass this value as a x and y in numpy array. Then we'll call the model. So we'll get an array of this one, and we are call our model, and we'll find out the intercept and slope and our equation. So we'll find out the value of a and b and so on. So by this way, you can calculate the equation that will be your equation y equal to a plus bx, and these are your predicted responses. Now, you want to plot the regression line for the given data point. So I will run this code. So again, it will, these are our different point and this is our regression line. So you can find out that a regression model is quite satisfying this relationship because there is a little bit difference between the observed value and the predicted value. So let me come back to PPT. So this is a one example of using the regression model to solve a problem. Now we'll go for another example. Yeah, this one. Now, this is our next example. Find the least square regression line for the following set of data. That is a minus 1 comma 0, 0 comma 2, 1 comma 4, 2 comma 5. So please write down this question and find out the regression line, that is a y equal to x plus b. So find out the coefficient of a and b. And if you want to plot this equation line on a matplotlib, so you can refer the Python code and you can draw the whole uh, model on the Python. Okay, so guys, please write down this question and solve the question and let me know what is the value of a and b. Okay. Any doubt or any query? This session will be open for another 5 minutes for discussion and question and answer. Thank you.